Okay, so practice. Let's just make it regular white. Okay, so the first couple is just find critical numbers. Find critical numbers. Okay, the first one is f of x equals x to the fourth minus 4x squared. Okay, so critical numbers, right? So the second one the same. Just find the critical numbers. So an sine square plus cosine x. And the interval is from 0 to 2 pi. Okay, and the last one, actually, yeah, can you find those, find extrema. So find extrema. And the function looks like this, so maybe I can squeeze it. I don't know, maybe not. Let's just... Okay, so let me write it here. So f of x is negative x squared plus 3x minus 5, and the interval, that interval I is from negative 2 to 1. Okay, so yeah, solve these and let me give you the answers. For the first one we have 0, it's one of them, and then we have plus and minus radical 2. So that's the first one. The second one we have 3 critical numbers, so pi over 3, and 5 pi over 3. Okay, and the last one I have maximum value is negative 3, and it occurs at x equals 1, and then minimum value is negative 15, and it's at x equals negative 2. Okay. All right, so I'll give you a summary of finding those extrema. So finding extrema, and then I have one more example, I think. Yeah. So finding extrema on a closed interval. Right, so closed interval, right, has brackets, right, and includes those two endpoints. Okay, so we have a function, let f be a continuous function. On interval AB. Okay, so then we have a couple steps, right? So the first one, yeah, so we need to find the critical numbers. So critical numbers of f on interval, open interval, right? This time a to b. So we're just kind of in the sense ignoring those endpoints, right, of that interval. Just finding critical numbers of the function. Then we can evaluate the function. For critical numbers and endpoints. And then we simply select, right? Select the highest, the greatest or least value. Values for, right, so maximum and minimum. Okay, so yeah, let's look at another example. Actually, yeah, I have two examples. One is short. Just a quick note that I get maybe this color note. That's something that I really haven't mentioned, but those critical numbers, I guess it's part of the definition, right? Critical numbers must be in the domain. Right? They must be in the domain of the function. In the domain of the function. Well, so right, it's kind of obvious, right, that the function basically needs to be defined, right, for that critical number. So here's example 6, and it goes like this: f of x equals 1 over x, and we can let's rewrite it x to negative 1, and then right, so f prime of x. And again, you can pause the video, it's a good exercise. Negative 1 over x squared. So yeah, so when you look at this here, right, so we could have that critical number, right, because that it's supposed to be an arrow, because derivative is not defined at x equals 0, right, because if we plug in 0 here, we get division by 0. So yeah, so is there a critical number at x equals 0? Well, the answer is no, because function is not defined for x equals 0. So no, because f is not defined at x equals 0. Right, so both, right, derivative doesn't exist or is not defined for x equals 0, but also the function. If the function was defined for x equals 0, then right, we would have that critical number at 0, but well, it's not defined, so we don't. All right, so let's do the last example for this section. I have example 7. and it goes like this. So we have a function f of x equals 2 sine x minus cosine 2x. And we're supposed to, the interval, we're supposed to figure it out on the interval on. So on 0 to 2 pi. Yeah, so find absolute minimum and maximum. Okay, so first step, it seems like a lot of problems begin with that derivative, right? So if you don't know what to do, take a derivative. Okay, so derivative of 2 sine x minus cosine 2x, right? So derivative of sine x is just cosine x, so 2 cosine x. Now we have derivative of cosine is the outside, right? So we have negative sine of 2x. We don't, right? So we have an inside function, right? The inside function is that 2x. So we didn't change it, but now we need to multiply it by derivative of the inside. So that's that. Let's simplify it a little bit. Plus 2 sine of 2x. Okay, so at this point, we make it equal to 0. And we have, and we can divide by 2. So cosine x plus sine of 2x. Yeah, at this point, you know, I always tell students, you don't need to remember some of those more not so basic identities, but it's good to know that they exist, right? So there's an identity for sine of 2x, double angle, right? Sine of 2x, and it's 2 sine x cosine x. Okay, so we're going to replace that second term. Okay, obviously I can't do it. Okay, ooh, that was difficult. Okay, so what do we have? Yeah, so let's replace that sine of 2x. So we have cosine x plus 2 sine x cosine x. So I'm solving this trigonometric equation. Let's factor cosine x out. So we have 1 plus 2 sine x equals to 0. So now we have right, we have two factors. It's either the first factor equal to 0 or the second one. So cosine x equals 0, or 1 plus 2 sine x equals 0. Okay, so cosine is 0 for our interval is from 0 to 2 pi, and yeah, cosine is 0 for pi over 2, right, for 90 degrees, and then to 70. So solution from the first equation is x equals pi over 2, or 3 pi over 2. And then from that second one, I guess, yeah, let me simplify this. So we have what? Sine x equals negative half. Okay, so between 0 and 2 pi, so negative half would be 7 pi over 6, I think, yeah. So 7 pi over 6, and the other one would be 11 pi over 6. So that's something that you should be able to do, you should know. Right, I'm talking about this part, solving this, and then solving that. And yeah, so these are critical points. I'm going to just kind of add, so critical points, we have 4 of them. And then, right, so we have, in addition to those critical points, we have those 2 endpoints. Right, so those 2 endpoints of the interval, those were 0 and 2 pi. Okay, so we need to check 6 different values. Right, so yeah, it would be good if you guys could try it, right? So f of pi over 2 would be the first one. I'm not going to do it. Maybe I'll do the first one. F of pi over 2, right? So that original equation was 2 sine of x. So that's going to be 2 times pi over 2. Nah, not like that. 2 sine of x. So 2, I don't need this parentheses. So we have 2 sine pi over 2. Then I have minus, not equals, minus cosine cosine 2 times pi over 2. Okay, so sine of pi over 2 is sine of 90 is 1. 2 times 1 would be 2. And here we have minus cosine of pi 2 times pi over 2, so that's just pi. So that's cosine of pi is negative 1. Okay, so that equals 3. Okay, so maybe what I'll do is, how should I do it? Maybe I'll list those critical numbers plus the endpoints here. So for pi over 2, we have pi over 2. Then we have 3 pi over 2. Then we have 7 pi over 6. And then we have 0 and 2 pi. Okay, so here are those numbers. I'll make them, but maybe... Okay, so we have 3. We calculated that. For 3 pi over 2 is negative 1, right? The value of the function. Here we have negative 3 pi over negative 3 over 2. The same for 11 pi over 6. 3 over 2. For 0 we get negative 1. And for 2 pi, negative 1. Okay, so we have, so this is the maximum, right? And we have 2 minima. And the lowest value, those 2. Okay, so that's it. That's the end of this section. And let me just remind you quickly what we did, right? So we have those and maxima, minima. So if I have a function that looks like this, right? So that would have a minimum, absolute minimum. This one would have absolute maximum. Usually I'm given also the interval, right? From here to there, or from here to there, right? And our task in this section was to find those lowest and highest values of a function. And there are a couple different possibilities. The first one is that, right, whenever derivative or slope, right, is equal to 0, so I have a tangent line that's straight line that's tangent to the graph at that point, right? So m will be 0, so derivative will be 0. So to find that point, I would take a derivative and make it equal to 0. The same thing here. Another option was the endpoints, right? So there's two endpoints here. Could be, right, the lowest, highest value, two endpoints here. And okay, so then, right, we cannot distinguish those endpoints from critical points or critical numbers. Those critical numbers were numbers where the derivative is 0 or slope is 0, right? So something like this. Or a situation where derivative doesn't exist, right? So if I have, for example, absolute value, right? So derivative doesn't exist here, right, at this point, but I can still have a minimum, right? I still have that critical number, critical point. Okay, so once we find those critical numbers, right, we list critical numbers plus the endpoints, and then plug in all those x's into the original function to figure out where that lowest value or highest values are. Okay, now that's it.